right, so example 2, it says, knowing that tangent of theta equals 15/8, what are the other trigonometric ratios for theta? Now, when you see this problem in the book, it's just going to be in words like this. They're not going to have a triangle drawn for you. I drew the triangle just to kind of guide you towards that idea that we want to draw a triangle for every one of these problems. Anytime you're doing anything right triangle trigonometry-wise, you want to draw the triangle. Notice I don't have any side measures written in the triangle yet, but I do have my right angle marked and I have my theta marked. All right, so right angle has to be in there, and you have to have one of your acute angles marked as theta. I'm choosing theta again because that's the angle that they're telling me, theta. They use some different Greek letter, use that Greek letter. It doesn't matter what they use. Now, if I go back, again, the two things I need to worry about is the Pythagorean theorem and SOHCAHTOA, right? I don't have any numbers yet, so I can't use the Pythagorean theorem, so I'm going to jump into SOHCAHTOA right away. SOHCAHTOA. Please write that word down for every single problem you see until you know how to spell it without looking it up. You have to spell it right because it's an acronym. If you spell it wrong, you put things in the wrong places. Okay? So it must be spelled correctly. Write it down every time until you know it just so easily. You can spell it as easily as you can spell dog. I say, how do you spell dog? You say D-O-G, obviously. You know, I want SOHCAHTOA to be that obvious to you. You know how to spell that easily. So, if they tell me tangent equals 15/8, and tangent is opposite over adjacent, right? That tells me that the opposite over the adjacent of theta is going to be 15/8. They told me what tangent was. I know what tangent is. So what tangent is equals what they tell me tangent is. Opposite side 15, adjacent side 8. If I go over to my triangle the way I drew it over here, I put theta up here. The opposite side, if I go across the triangle, that's the opposite side. If I go across to the right angle, that's the hypotenuse. The third side is the adjacent side. Opposite is 15. Adjacent is 8. Just like that, I now know 2 of the 3 sides of the right triangle based on the trig ratio they gave me. If they had said sine of theta is equal to 15, or they couldn't say sine. Sine has to be less than 1. But suppose they said sine of theta equals 15/8 though. Then opposite over hypotenuse. Opposite 15, hypotenuse 8. That obviously doesn't work because the hypotenuse is supposed to be the longest side, right? So you could say that's impossible, because that would be impossible. But again, whatever they tell you, use that information to identify what it looks like in order to figure out what sides they're giving you so you can fill in your triangle with 2 of the 3 sides. Then the hypotenuse, now that I know 2 sides, I use the Pythagorean theorem again. So leg squared, 8 squared is 64, plus leg squared, 15 squared is 225, equals hypotenuse squared. We call the hypotenuse C. All right, so 8 squared 64 plus 15 squared 225 equals hypotenuse squared. We don't know it. 64 plus 225 is 289. So C is going to equal the square root of 289, which happens to equal exactly 17. Most of the problems in your book have nice, pretty integer values for all 3 sides. Okay, go through the Pythagorean theorem every time anyway, but expect that most of them come out to nice, pretty numbers like that. They don't have a lot of square root answers like we did on example 1. It says, what are the other trigonometric ratios for theta? So, sine of theta equals something. Cosine of theta equals something. We already know tangent of theta. Cosecant of theta equals something. Secant of theta equals something. Cotangent of theta equals something. Each of them being a fraction. What does cotangent equal? Reciprocal of what? Tangent. Tangent is what? 15/8, so the cotangent is 8/15. That one we could have done without even trying, right? We didn't have to draw anything. They just said, hey, the tangent is this, what's the cotangent? Well, just flip it over. There you got it, right? The rest of them, I need to find sine and cosine to find these, right? So I want sine and cosine off of SOHCAHTOA. I reciprocate to get cosecant and secant. Sine is opposite over hypotenuse. Opposite is 15. Hypotenuse is 17. So cosecant is the reciprocal 17/15. Cosine is adjacent over hypotenuse. Adjacent is 8. Hypotenuse is 17. Cosine is 8/17, which means secant is 17/8. They give you one, you can find the rest. The one they give you makes the triangle. The Pythagorean theorem finds the missing side, and then SOHCAHTOA finds sine, cosine, tangent, and then reciprocate to get the other ones. One slight thing that I want to bring to your attention that they might throw at you, that how to handle it. So suppose they tell you this. Suppose they say secant of theta equals 5/4. Is secant part of SOHCAHTOA? SOHCAHTOA is sine, cosine, tangent, not secant, right? So if secant is 5/4, what do we know that's the reciprocal of cosine? So if they give you one of those other three, cosecant, secant, or cotangent, make sure that you write down its reciprocal function. So they give you secant, you can identify cosine, and then cosine, if we look at SOHCAHTOA, cosine comes from that, so this is adjacent over hypotenuse, and now we know two of the three sides, right? So I draw my triangle, I draw my angle, move down here, just be different. If the angle's down there, this is the opposite, there's the right angle, that's the hypotenuse, this is the adjacent. Cosine is adjacent over hypotenuse, so adjacent is 4, hypotenuse is 5. We're missing the opposite side, we'll call A. A squared plus 4 squared equals 5 squared. A squared equals 9. So A equals 3. And now, opposite over hypotenuse, 3/5 is sine. Opposite over adjacent, 3/4 is tangent, and so on and so forth. So again, if they give you one of these that aren't sine, cosine, tangent, use it to get what it is, sine, cosine, or tangent. Use SOHCAHTOA to find out what sides they're giving you, and then find all the missing pieces. That's as challenging as a problem you're usually going to get tonight. So instead of giving you sine, cosine, tangent, it might give you one of these. So that's how you handle those. Your homework is all this type of problem. Practice it, understand it, and have this really, really, really well known, because this is the foundation of trigonometry. We're going to fall back on this a lot. So you need to make sure this is understood quite well to move on to bigger and better stuff.